Thanks, Dave. Good afternoon, everybody. It's awesome to be here in Switzerland again. This is my third time to Switzerland. It's the coldest time to Switzerland, I'll say. But I did warm up yesterday on some good fondue, which is one of my favorite foods. So I really appreciate being back here. And welcome, everybody. Thank you very much for coming. So I'm the Chief Technology Officer of Microsoft Azure. I've been in Azure now for about 8 years, which is 100 years in cloud terms. It's been an incredible journey on the way to having cloud become going from something that nobody really knew anything about to something that everybody believes, or just about everybody believes, is part of their future and part of the transformation that their companies are undergoing. I've got about 45 minutes this morning, which isn't a whole lot of time, to give you a kind of broad overview of some of the things we're doing in Azure. And I want to set the framework for what I talk about by focusing on the 4 areas where we believe we differentiate individually, and where as a collective we believe that we differentiate with respect to other cloud providers. First, intelligence. I'll talk about what we're doing with ML and AI and focus on a few key areas that demonstrate kind of our thought leadership there. Then hybrid. We believe we are the cloud that really understands hybrid the most deeply. Productive. We also believe that we have a long legacy of developer tooling, and we've actually transformed in some ways to adapt to the modern world of open source, and I'll talk a little bit about that. And then finally, trusted. We believe that we are the most trusted cloud. Microsoft has a long history of being a company that has been heavily invested in cybersecurity and trust and customer privacy, and so I'll talk about some of the things we're doing there. Let's start talking about intelligence. And when we talk about intelligence, we're talking about the ability to infuse applications with AI, with cognitive, and we've got a holistic approach to this that goes from the very top of the stack to the very bottom of the stack. And so this slide just shows you some of the areas, some of the particular features or services that we've got in this category. And I'll start by talking a little bit about the very top of the stack, because if you talk about the top of the stack, it's services that are canned that provide some kind of AI or cognitive service for end users. And one of the examples that we have there is the bot framework. This is the interactive chat assistant, the kind of interactive tool that is useful for many different scenarios, including customer service is a very popular one, technical support, even internal systems like HR support is one of the areas that we've seen customers adopt the chat framework for. And this framework makes it very easy for a developer to create an interactive dialogue with sub-dialogues that go into special topics related to how the customer wants to interact. And a chat framework is not much without the ability to understand language and to respond to it. And so that's where the next set of services come into play, and those are our cognitive APIs. I'm going to talk more about our cognitive APIs in a few minutes, but briefly, the cognitive APIs are ML as a service that developers can very easily integrate into whatever application they're designing. They include things like speech and vision, and in the case of the bot framework, it includes language understanding, so that you can take the text entered by a user and very quickly decode it into what is the object, what is the context, what is the action that the user wants, and then respond to it in your chat framework. At the next level below the canned services, comes the platform for developing machine learning and AI. And that's where we have services like Azure Machine Learning, which is an interactive studio for you to create machine learning experiments, take data, curate the data, run the experiments, produce outputs, play with the data, and basically refine the algorithms to the point where you've got them in a form that you can then create a service out of them with an endpoint that you can call from your application and get back results from the model. We also have something relatively new that we introduced last fall called Machine Learning Workbench, which is an interactive application that lets you curate data as well as create experiments right there on your desktop, and also refine and create the models from them. Then, below that, we've got our infrastructure. And this comes where we've got things like our data science virtual machine, a virtual machine that comes pre-built with a whole bunch of machine learning frameworks and runtimes that you can very easily launch and then get running very quickly. At the very bottom, we've got an infrastructure that we're optimizing for AI and ML, and this includes making sure that we've got the latest generation GPUs in our cloud. So we've got the latest GPUs from NVIDIA, like the V100 and the P40s that are optimized for machine learning inference and machine learning training, as well as from AMD. But not only that, we're investing in creating our own differentiated infrastructure for machine learning. I'm going to talk more about that in a few minutes. It's a program we've got called Brainwave, which is built on field programmable gate arrays, or FPGAs. And this is something that we don't see any other cloud provider doing, is going in this direction, which we believe has the promise of what we call real-time AI. And then finally, you can see across the bottom there a whole bunch of data services. And our data services, of course, necessary. Machine learning feeds off of data, and so we have to have very scalable, very powerful data services, and those include things like Cosmos DB and SQL Server and Azure Data Lake Analytics. Also, we take and infuse those with machine learning because data has gravity, and you want machine learning close to the data. In so many cases, you want machine learning algorithms right there in the database. And so this is where we inject the support for R, for example, a machine learning runtime that you can have R scripts running right there, sitting in the database, processing the data without having to take the data out of the database. Now, let me go back to cognitive services. I think this is one of the coolest suite of services available on the platform. There's about 30 different APIs, and you can see the categories up here. And I mentioned a few of them briefly just a minute ago, like the vision APIs that include object recognition. They include facial recognition. They include facial sentiment analysis. They include text sentiment analysis, language understanding already mentioned, and they include knowledge and search, and the Bing search APIs are also available there for you to use. These APIs don't just come in canned form, but you can customize them. So this is one of the key requirements for most domains, is that the standard models for something like language understanding or speech recognition aren't tailored for the environment that you're trying to target. For example, if you're dealing with a factory floor and you want speech recognition to be there on the factory floor for the technicians, the standard model might not understand the terminology being used on your factory floor. So you want to train a model to understand your own specific terminology and actions. Many of these, actually, APIs, including the speech recognition API, are customizable, where you can use transfer learning, where you take our base models and then augment it with your domain-specific training. And I'm going to show you a quick example of that here with the speech API. Now, the speech API is an API. Log in here to my machine. The speech API is an API that will take language and translate it to text. And it supports a whole bunch of different languages. I'm going to show you an example of how you can customize the standard model with custom language models. And there's two ways that you can customize these language models. One is with just text, where you feed in to the model text snippets that it will then understand and bias for as it goes and does its speech recognition. And the other one is actually even richer, which is to give it audio clips with the corresponding text, so then it can do a more precise match. The example I've got here is from a Ignite talk I gave last summer, and the talk was on Azure Data Center internals. And this Azure Data Center internals talk, let me pull up the transcript of the standard model, because the standard model doesn't know a lot of specific terminology, doesn't know my name, unfortunately, yet, which is kind of disappointing. You can see here, when I gave the talk, I said, hey, I'm Mark Russinovich. I'm Chief Technology Officer of Azure. Well, I said here, my name is Marcus Cinema. So that is, I'm not a cinema. My name is Mark Russinovich, but the standard model, that's the closest it could come with Mark Russinovich. And actually, my pronunciation's a little slurred when I speak, and I say my name is Mark Russinovich. Hard for the language model to actually separate Mark and Russinovich. So that's what you get from the standard model. Now, we can do a lot better, and there's a number of other mistranslations here in the transcript. So what I did was I created a custom language model. And this custom language model, just like I said, has just little snippets that are pieces of text that I saw being mistranslated in that transcript. What I can do with this now is upload it as a custom training set that will then be augment that basic model for an improved degree of accuracy. But I also went a step further, and I created a custom speech model. And that custom speech model, what you do with it when you upload it is you give it wave files of the speech with the corresponding pre-translated text. So this is effectively labeled data. And you can see that I gave it a clip speech2.wave and said that that should be translated into Mark Russinovich. Let me pull that up here. This little clip of speech, which I've got bundled here. Mark Russinovich. So you can see that that's hard for even me to understand what I said there. But I uploaded that, and you can see that here are the data sets. I've uploaded them both, the acoustic data set, which is what we just heard, and the language data sets here, into the Cognitive Services Customization portal. What I can do now is go take a look at the accuracy of the different models against the various audio clips from that transcript. And what I've got here are four evaluations. At the very bottom is the standard model. And for each of these, you can see that the evaluation comes back with a score. What percentage of words were incorrect? Because what I've done is given it the correct transcription of this in the spirit of training it. And you can see that with the standard model, it had an error rate of about 24%, 25%, which is basically 1 in 4 words it got wrong. And that's because there's so much technical jargon and my slurred speech and other aspects that didn't fit with the standard model. You can see that the next one up, this is the custom language model. And this is the one where I just gave it snippets of text. And the accuracy improved to about 14%. So pretty big jump just there by just giving it snippets like the text Mark Russinovich. The next one up is the custom speech model. And this is the one where I gave it the audio clips with the corresponding text. You can see that the accuracy there got down to less than 10% error rate. But what's even better is when you combine those two, I combined the custom speech and the custom language models and trained it with that and got the error rate down to about 3%. And for each one of these, you can see when you go into details, the example of how the transcription, so this is what I said it should be, and this is what the decoder came back with, basically the trained model. So you can see I told it Mark Russinovich was what is in speech wave 2, which we heard, and then you can see the decoder got that right this time based on the training model that I gave it, the training data I'd given it. Now, that is really cool, but what do you do with this? So I've got some models. What you can do at this point is go deploy the models. And you deploy the models. At that point, you have custom speech endpoint. So if I scroll down here, you can see that I've got different, here's the REST HTTP endpoint where I can call now from my application, give it snippets of speech in various different audio formats, including WAV file, and it'll come back with the translated text. It can take in short snippets, or it can take in very long, multi-hour talks, like my Ignite talk. And then, what's even kind of cool here is that you can play with it right here in the portal, that speech API, the endpoint. So I can do the test. I just fed it speech wave 2, and you can see it came back with the correct translation for Mark Russinovich. So that's an example of our cognitive APIs and just how you can customize those for your specific domain. And like I mentioned, there's a bunch of other different customizations across those API categories that you can customize for your domain. I talked earlier about how we're optimizing our infrastructure for machine learning and AI as well. And one of the approaches we're taking here that I mentioned was unique was the use of field programmable gate arrays. How many people have heard of FPGAs? So those of you that have heard of it have probably been in the industry for a while, because these things come and go periodically. Every 10 to 15 years, FPGAs become hot, and then they go away, and then they come back. I think they're here to stay this time. And I think they're here to stay this time because the technology has caught up with the promise of FPGAs. FPGAs kind of were hot in the 80s, for those of you that weren't around to see that back then. We've been using FPGAs at Microsoft in Azure for about the last 4 or 5 years. We've been working on them at Microsoft since about 2010. What field programmable gate arrays are is you effectively think of them as soft logic. They're like hardware, but you can program the hardware. So it's this intermediate point between hard-coded logic inside of an ASIC or a specialized processor and software on a CPU or GPU, which is much more general kind of processor. This case, it's somewhat general because you can program it, but it has characteristics that are much more like hardware, like custom hardware, ASICs, in terms of their efficiency. And for very parallelizable workloads, they offer amazing efficiency over something like a CPU or a GPU. We've been using them in our network infrastructure to accelerate our networking stack by offloading our software-defined networking algorithms onto the FPGA, and that allows us to get the highest bandwidth and the lowest latency off our virtual machine networks of any public cloud provider, up to 40 gigabits per second, and from one VM to another VM inside of the same cluster, latencies of 5 microseconds, which is bordering on the kind of latencies you'd get with something like InfiniBand networking, but this is on TCP/IP over Ethernet inside of our networks. And that's because of the power of these FPGAs. In the context of machine learning, the way that we're applying them is by programming them with machine learning deep neural network models. And this allows us to achieve something that we call real-time AI. What do I mean by real-time AI? If you talk about inference or scoring, there's 2 types of machine learning. There's training the models, which you typically do on something like a GPU or a specialized training processor. And then there's inference or scoring, which is what we just saw with the cognitive API, where you feed it a piece of text and you get back a prediction of what the result is. We're using FPGAs for inference. And if you take a look at GPUs, GPUs are great for training. They are hugely parallel, but they've got very deep pipelines, and that means you need to feed it a lot of data to get maximum utilization out of it. And then the deep pipelines mean that you have long latency in getting an answer back. So they're great for training, but not great for inference. When you talk about inference, really you want to be able to feed individual requests into the processor and get back answers very quickly. With FPGAs, we can do that and achieve real-time responsiveness inference. And I'm going to show you what that looks like by showing you a brainwave demo. And in this brainwave demo, here, what I've got is a comparison of GPU inference versus FPGA brainwave inference. Now, first, what I'm showing you is the GPU. What I'm doing is feeding it batch size. Batch size means here's 256 queries or requests to go score. And you can see that on the GPU, it is great at these kind of batch because it's very parallelized, it's got very deep pipes, and so it drives the utilization up to close to 40 teraflops per second, tera operations per second. But you can see when I drop the batch size that the efficiency of the GPU goes down and down and down until we're only able to get a fraction of that hardware being used. Because we're giving it such small batch sizes, it sits most of its time idle. Now, when I take brainwave and I feed it individual requests, you can see I'm feeding it batch sizes. The batch size that cross here, 64, 32, 16, all the way down to 1, that we're driving it at 40 teraflops, and that remains constant even as I reduce the batch size, all the way down to 1. And that means I can feed it 1 request a second. As fast as I can feed it 1 request a second, it's able to respond and deliver that kind of throughput. Not only that, but you can see here's the latency on the GPU in scoring. It's about 68 milliseconds, and here's the latency from brainwave, which is less than 1 millisecond. And that's why we call it AI, or real-time AI, because we can feed it individual requests. It's just as efficient with individual requests as with batches, and it has much lower latency on the scoring. And we've got this right now. We're using it internally in Bing. You're going to see us bring this out and make it publicly available to customers in the very near future in Azure. And this is just the first step on our path to accelerated machine learning training or inference. We'll also have accelerated machine learning training under the works too in Azure, and this is part of our differentiated hardware infrastructure that we're working on. Let me switch back here. So that's a quick look at intelligence. Let's switch and talk about hybrid now. And hybrid, we believe, is in our DNA because we've been with many customers through this whole client-server journey. Many of our customers are using Microsoft technologies on premises. And so we're in a great position to help customers take advantage of the cloud from their on-premises networks or take advantage of on-premises networks from the cloud. Both directions, we believe, are important because hybrid, we believe, is here to stay. Many companies, despite companies even saying we're aggressively moving to cloud, it takes years to actually get completely off on-prem, even if you say you're going to get completely off-prem, which many customers at this point believe that they're going to have something on-prem for the foreseeable future. And so this is a huge area of investment for us. And you can see that we focus on hybrid connectivity between on-premises and the cloud in several different ways. One of them that is one of the most powerful and differentiated is just identity. Because the heart of the enterprise is identity. This is the way that you control access to everything. Access is the way that you lock down and monitor and control your networks, whether they're on-premises networks or cloud networks, or a combination of the two. 95% of enterprises use Azure or use Active Directory, Windows Server Active Directory, on-premises for identity. And Azure Active Directory has seamless integration with on-premises Active Directory for single sign-on experiences to cloud services through AAD. Not just Microsoft cloud services like Azure and Office 365, but also roughly 3,000 different SaaS and PaaS applications through the connectors that we have. So if you want a single sign-on to Twitter, you can do that through Azure Active Directory. And there's even special capabilities in those connectors like self-management, automatic management of the Twitter password, so nobody ever sees the Twitter password. They only authenticate to Twitter using their own. And that's what you actually need to have control over access. If the person that's in charge of the social media channel leaves your company, you want to be able to shut off their access to your Twitter channel immediately. And you can do that in one place with Azure Active Directory. Another example is in our data services. So the cloud offers this infinite storage. That's the promise of the cloud. On-premises storage can be more limited, but you can take advantage of cloud for infinite storage seamlessly behind an on-premises endpoint by leveraging things like Azure SQL Stretch Database, which allows you to create a database that is backed seamlessly up into the cloud. The data that gets put up into the cloud is the cold data, it's encrypted, and the customers or the applications using that data in your on-premises network have no idea that the database is partially on-prem and partially in the cloud. And that's just one example there. And then another example is in security and management. This is a huge investment for us. Operational management is, of course, absolutely essential for being efficient in the cloud. But we believe that you want to have one way to manage, whether it's on-premises, in one cloud, or in multiple clouds. And so Operations Management Suite, which allows you to manage VMs or servers, whether they're on-premises, whether they're in Azure, whether they're in another cloud, you can do it from the cloud in a consistent way across the whole thing and get deep operational insights as to how your VMs and networks are working, as well as do security controls across your on-premises and your cloud networks as well. We also are working hard on helping those companies that want to move workloads from on-premises to the cloud do that. And one of the ways that we do that is with a relatively new service. In fact, it just went to general availability today. It's called Azure Migrate. And this is an assessment tool where you can point it at your on-premises VMware resources, and we're going to support, of course, Hyper-V in the near future. But it will go and map out the topology of your applications in those virtual machines, and then give you guidance about how to best migrate them. What size of virtual machines should be using in the cloud? What kind of plan, what kind of dependencies are there between those virtual machines so that you can then plan which ones have to move together. And then once you're ready to move, once you've done this assessment, and also we'll give you cost estimates too about that migration. Once you're ready for that assessment, then you can use Azure Site Recovery, for example, to move those virtual machines up into the cloud with a plan that will orchestrate that movement. We see many customers taking advantage of Azure Site Recovery to quickly move their on-premises workloads into the cloud, basically lift and shifting, and then later going into modernization. But one of our biggest differentiations when it comes to hybrid, it's really something that no other cloud has anything like this, is Azure Stack. How many people have heard of Azure Stack, just as a raise of hands? So quite a few of you have. Azure Stack is effectively Azure on-premises. It's the same software stack from the Azure portal to the Azure Resource Manager APIs to some of the PaaS services, and then infrastructure services, cloud networking and storage, or compute network and storage, on top of its own custom on-prem fabric, so that you can take advantage of the Azure ecosystem in your own data center. And what I mean by Azure ecosystem, I mean application developers, ISVs, and your own application developers can write applications, can write Azure Resource Manager, complex multi-service applications that work on-premises and work in the cloud without any modification. And ISVs can publish solutions that you can then purchase and run in Azure Stack on-premises or up in the cloud. And the other part of the ecosystem besides developer ecosystem, besides ISV ecosystem, is expertise. So when you've got some workload that you want to run on-prem, you want to future-proof it, or you want people to know how to operate or interact with that application, all you do is put out a job listing for somebody that knows Azure, and then you get somebody that knows how to operate your private cloud. It's not put out an advertisement for somebody that knows how to, that's a good technical person that you need to bring in and then train on your own specific Snowflake private cloud. Here you're taking advantage of the Azure ecosystem. And there's different scenarios that Azure Stack is good for. If you think about Azure where you want it, in a form factor that's the smallest 4 servers, you can put this basically inside your data center. You can put it in, we see customers putting it in all sorts of places, on oil rigs, in mines, on cruise ships, in factories. And so it's not just, or in countries where public Azure is not present and may never be present. There's places of the world where Azure might not be present, and for latency requirements or for data sovereignty requirements, you need the data to stay there, but you want cloud there, and so you can take advantage of Azure Stack. But Azure Stack really is also part of our edge strategy. We found that lots of customers want it for, hey, I've got security concerns for this workload. I need to keep it on-prem. I've got data sovereignty concerns. I need to keep it on-prem. But if you take a look at the factory floor scenario, that is really an edge scenario. The factory floor is basically a giant Internet of Things scenario. And Internet of Things, really you want intelligence to go out to the edge. And so if you take a look at the factory floor, you want machine learning happening on the factory floor in real time, optimizing that factory floor. You might also want the data to go up into the cloud so you can do optimization deeply in the public cloud. But this fits into what we consider our intelligent cloud, intelligent edge strategy. Intelligent cloud is the services I talked about before. And if you talk about IoT, pumping data up into the cloud and getting insights out of it using those machine learning algorithms and data analytics platforms I talked about is, of course, a key part of that. But in some cases, you might want to push that intelligence down to the edge. And you can do that with Azure Stack, because Azure Stack, then you can run those IoT applications there close to those IoT devices like the factory floor devices. And speaking of Azure IoT, we've had a huge focus in IoT scenarios, not just with Azure Stack, but with specific support for IoT. And we've got a few different offerings that we've had out. One of them is called IoT Suite. If you want a customizable solution, you can start with IoT Suite, which will get you up and running in minutes with some basic canned scenarios, like predictive maintenance is one of the most popular ones, where you're going to feed it data from your devices, and it's going to run machine learning algorithms on it to predict when something's going to fail. And we see many customers taking advantage of this. Rolls-Royce, for example. Aircraft engines using predictive maintenance here with IoT Suite to predict when an aircraft engine is going to fail. Then we have something new called IoT Central, and I'm going to show you IoT Central in a minute. This is basically IoT SaaS, and this is, when I talk about a vision of where the cloud is going, it is a platform where you can focus on your business problem, and we take care of everything else. And with IoT Central, it lets you focus on your IoT scenario, and we take care of all the plumbing underneath, and I'm going to show you what that means in a minute. And then in the context of hybrid, there's IoT Edge. This fits into that intelligent cloud, intelligent edge I was talking about, where you want to push intelligence down close to those devices. Because if you take, for example, we've got customers in retail or factory floor where they're taking images of different products, and they're doing quality control on them. Now, most of the images are high quality, or they're standard, they're not anomalous. And so there's no reason to send those images up into the cloud. What you want to do is only send the anomalous ones up into the cloud, because those you're going to want to go and investigate, explore, understand what's going on. And so what you could do is what you'd like to do is actually push those vision recognition APIs down to the edge, right next to the camera, have it process those images, and then only send the anomalous ones up. And that saves you huge amounts of bandwidth. And also you can get low latency response then to those anomalous images. And so customers are taking advantage of that by pushing ML down to the edge. And what does that mean? How are we supporting that? If you take a look at IoT, IoT has IoT Hub at the core of it, which is the gateway, basically, from the cloud to the on-premises devices. This allows the devices to talk up into the cloud and allows you to manage the devices from the cloud. There are your things, your devices. And then you want to get insights. This is where you have the analytics on the back end. This is where you have responses to those analytics, like, oh, there's something wrong with this device, or the temperature has changed. I need to go take an action. I need to change the temperature control, that is an action that would go back down to the device. So the typical flow is this way. Data goes up, it's analyzed, actions go back down. But in the case of something like vision recognition, what you really want is to move that down and take respond right away, get intelligence right there, and that is intelligent edge. The way we're supporting that is if you go back to take a look or recall what I talked about Azure Machine Learning Workbench, you can go and create and train a model and then package it up as a Docker container and then put it through IoT Hub, deploy it down to your devices. So deploy that machine learning model down to the device itself, which could be a vision recognition model, and then that is totally managed within Azure IoT. You can also push Azure Functions down to the edge as well. So as part of the whole overall application that operates on the edge, where a function might respond to a specific action, like this particular object looks faulty, take an action on it, and go take some response that might mean sending something up into the cloud. But IoT Central, that is our one-stop shop for you getting started very quickly and easily with a solution that lets you focus on your IoT scenario, your devices, and what they do, and how you want to respond to them, and lets Azure take care of everything else. Because if you take a look at what an IoT solution consists of, it's IoT Hub, it's the Event Hub gateway, it's the connection between the devices in the cloud, it's the stream analytics processing that happens on the back end, it's the big data analytics, it's the real-time, near real-time insights that works on the data as it flows in to analyze that data and understand, hey, the temperature has been below this threshold for this amount of time, let's take an action. All of that is built on top of PaaS services. But if you just want to focus on the problem, you're not really interested in the PaaS services, you're interested in this is what I want to happen when the device temperature goes above a certain threshold. And IoT Central is designed to let you focus on exactly that part of the problem. Let me pull up and show you just how easy it is to get started with IoT Central. So if you do a search for IoT Central, you will find here IoT Central, an application wizard that will let you, in one page, define an IoT solution just by putting in an application name. You'll get a custom URL for it. You pick the Azure Active Directory that you want to manage the identities and access control for that solution, that application, Azure subscription, and what region you want it in. And then you pick from an application template, which can be simple dev kits. There's a free 30-day trial version, so you don't even have to pay anything to get started with this and try it out. And then you press create. And within literally a couple minutes here, this would get created. Now, to save us the time of waiting for that couple minutes, I've already got one set up here, following those exact steps that I showed you. And here's the dashboard that I get as a result of that. Now, you can go and provision real devices in that sample device, an MX chip developer kit or a Raspberry Pi. You can also, just to test out and understand how this thing is going to work without actually having to go get physical devices and play with them, it supports simulated devices. And I've got a couple simulated devices here, including a simulated MX chip device. When I click on that, I've got the kinds of telemetry that would be coming off that device, synthetically generated, so I can look at what that would appear like in IoT Central. I also have various settings for the device, like the voltage, the fan speed, the current amps that are programmed for the device, properties you can set, and all of this is customizable. I can customize the telemetry, I can customize the settings and the properties, and then I can also create rules. And those rules are, hey, when the temperature goes up a certain value, then take this action, change this property, change this setting. This is also set up to very easily make it possible for you to manage securely the application, where there's roles that are defined. If I go to roles, you can see that we're focusing on the various personas that are involved with an IoT application, from the application administrator that is created and has control over the whole thing, to the application builder that is building the IoT application, to the application operator that is just looking at the results, monitoring what's going on with the application, and maybe registering new devices. But the application builder is the one that's defined the settings, the properties, and the rules. And then, as you can see, coming soon are custom roles. So that's a quick look at IoT Central. And I recommend that you go try it out with a synthetic device or go pick up an MX chip device and plug it in, and you can get started and see how straightforward it is to get started. And on the back end, like I said, there's probably close to a dozen PaaS services implementing what you see there in IoT Central without you having to worry about any of that. Okay, next, let's talk about productivity. And this is where I think it might not have caught up with everybody in this room yet, that Microsoft has become an open source company. And some of you might be squirming in your seats hearing me say that Microsoft is an open source company, saying, really? Are you really an open source company? We really are now an open source company. And this wall of logos right here just shows you the kind of partnerships and support we have for open source technologies in Azure. In fact, you're going to hear from Patrick after me from Docker. We've had a collaboration partnership with Docker that goes back several years, so deeply that we've got a person on the Windows kernel team that is a Docker committer because we worked with Docker to integrate Docker support into Windows Server itself. We're ranked number 1 and 2 in GitHub for the most projects published in GitHub and the most developers that have contributed to projects in GitHub. And when we've supported open source, we've also contributed many things to open source. Visual Studio Code is just one example. PowerShell has contributed to open source. We've taken SQL and put it on Linux. We're so deeply open source that developers, in many cases inside of Microsoft, reach for open source first when they're going to go create something, because open source now has just become part of the way that we do things. But the other ways that we're productive is in supporting the whole life cycle of an application. So we've got a huge focus on CI/CD, continuous integration, continuous deployment, which is what DevOps is all about. If you take a look at Visual Studio Team Services as one example of that, it's a as-a-service support for source code control, for release management, for integration testing, for load testing, all of that, and release out to production. All of that within one very scalable, very mature at this point, it's been around for 5 or 6 years, platform that's used by literally tens of millions of developers. And then we have support for platforms and frameworks that people want to use to create their applications. You saw some of the logos on the previous slide, which includes Linux, distros, Docker, but we also support open source frameworks like Kubernetes, which is a very popular orchestration platform. We've got a managed service called AKS, which is aimed at making it easy for you to just get up and start running Kubernetes without having to worry about cluster management, where it's all done automatically for you. But Kubernetes and orchestration management really is, I think, a step onto where we're ultimately heading, which is serverless computing. So a lot of you probably have heard of serverless computing, and serverless computing is most commonly associated with functions as a service, or FaaS. The benefit of serverless computing, if you take a step back, is that you don't have to worry about the underlying infrastructure. You just worry about the application. Like I said, that is the future vision of cloud we have, is you focus on your business logic, you focus on your application, and the platform does everything else. And this is a great example, functions as a service on the path to that vision in one particular domain. So what is it exactly? The strict definition of serverless is that it abstracts the servers, of course, otherwise it wouldn't be called serverless, even though there's servers still there, which confuses some people. Servers don't go away, they're still there, but it's serverless because you don't pay attention to them. And that means that it's automatically scaled. So if you're actually managing servers, besides patching them and determining what versions they are, and you're also responsible for scaling them out, which you would do in a Kubernetes cluster. You'd put auto-scaling rules on top of it. Here, you don't have to even do that. The platform automatically scales to handle the load that is thrown at it. And it's event-driven. So another common characteristic of serverless platforms is that they are pieces of code that get triggered in response to some event, some action. It could be an object being dropped into object storage, and then you want to go do something, and the canonical example is I want to go generate a thumbnail off of an image that was dropped into object storage, and you can do that by having something registered to watch for that object being dropped there, and then kick off a function that does the thumbnail conversion. And then finally, microbilling means that you only pay for the code as it executes. If there's no invocations of your code, you pay nothing. So only when an object shows up in that object storage does a function actually execute, and you get charged just for that function's length of time that it executes and the amount of RAM that it consumes. And so that's really serverless, and the benefits are pretty obvious. When you can just write the code and say, here, cloud, run this code whenever this happens, I don't have to worry about servers, I don't have to worry about auto-scaling, I don't have to pay for those functions laying around doing nothing, then the benefits are I get time to value that's incredibly fast. I can have solutions stood up in minutes that used to take a long time. And it's not just functions as a service, but even going higher level. And I want to show you an example of another serverless application platform we've got called Logic Apps. Logic Apps is serverless integration workflow. And serverless integration workflow, that's a bunch of words that sound kind of meaningless thrown together. But let me put it in a nutshell by giving you a scenario that's common to just about every company. And that is social media feeds. You want to watch for customers that are saying bad things about your company. Why do you want to watch for them? Because you want to respond to them. You want to understand what's the customer experience. Why are they unhappy? So with if you went to your IT people and said, I want you to monitor for #Contoso tweets. And for every one of those tweets, I want you to determine if it's a negative tweet or a positive tweet. And if it's a negative tweet, I want you to look in our CRM database to see if that Twitter handle is registered with one of our customers. And if it is, I want you to look up what account manager has that customer. And then I want you to determine if they've emailed with that customer more than once, which would mean they've got a personal relationship most likely with that customer. And if they do, then send that account manager an email saying, this customer of yours, here's their tweet, it's negative, you should follow up with them. Imagine going to an IT shop a few years ago and asking them to build that application. And it would be probably weeks or several months of architecting it, another several weeks or months of building it and then deploying it and testing it and then getting it ready for production and then ongoing maintenance of this. What I'm going to show you is that application in Logic Apps, which if you're familiar with Logic Apps, you can deploy, write and deploy. If you're deeply familiar and you understand that scenario like I just described it, you can deploy it in just about half an hour. And once you deployed it, it's up and running, auto-scaling. You pay only for it when it executes, only when those Twitter tweets come in. So I'll start by tweeting here. #Contoso is really, really bad, so it's a really negative tweet. And so now I've tweeted that. Now let's go take a look at this app. This app, first, there's steps that you program right here. You can do it visually. You can do it in text. So I want to, whenever #Contoso tweet is seen, and I'm polling Twitter every 4 seconds, then I want to detect sentiment. And this highlights Logic App's ability to connect with other services. So here you can see that I'm actually connecting with Twitter and with a cognitive API to categorize the sentiment with a function which says if the cognitive API comes below a certain threshold, then what I want to do is kick off an engagement workflow. And if I go back, the engagement workflow does the things that I just described. And all of this is done with just a few clicks, no code. When an HTTP request is received, do a dynamics query for that Twitter handle in the accounts database, which you're going to see open up here in a second. So look in the accounts database for that. Then do a graph query, which queries the inboxes of my sales reps to see if they've interacted with this account. And if they have more than once, here you can see if more than once, then go send an email. And there it is. So negative tweet, Contoso is really, really bad. So I got the email because I was the one registered for that account, that Twitter handle, and now I can go follow up with that user. So that's a quick look at Logic Apps and just how serverless, the power of serverless is realized with something like that already. Now, I want to conclude by talking about trust. And trust, like I said, is one of those areas that Microsoft has really invested deeply in for a long time. And part of that trust means keeping data where you want it to stay. And part of that is realized with our global footprint of Azure data centers, which are in 42 regions around the world, not in Switzerland at this point, but in Europe And we're looking at all countries, we're evaluating all countries, and so we're by no means done with our global expansion. Of course, all of the places where our customers are and where they need their data to be, whether for latency or data sovereignty purposes, we're strongly evaluating. And we have new regions in South Africa, we have new regions in France that had just opened up at the end of last year, and so we continue this global expansion. We've got more regions than any other cloud provider. If you take a look at one of the representations of trust is certifications. Certifications represent just how good we are at implementing security controls and privacy controls. They also help unblock business where customers are regulated and they cannot even host data in a cloud provider without having the cloud provider adhere to these certification standards. And you can see we've got more than any other cloud provider. We've got close to 80 of them right now. The second most by any cloud provider is around 60. And we continue to grow that list out. And then when it comes to managing compliance, we've just recently released, we GA'd this just last week, at Microsoft Compliance Manager. How many of you are worried about GDPR? So the rest of you all have it covered? You're all set? Well, in the US, we're actually a little bit freaked out by it, and so lots of our customers are saying, what do we need to do to be GDPR compliant? The deadline's coming up. How do we keep track of where we are? And so this tool is aimed at exactly that kind of problem, allowing you to measure your compliance against the controls across those certifications down there, those standards down there, GDPR, ISO 27001, 27018, and it will report where we are across Azure, Dynamics, and Office in adhering to those standards. So that's the bottom blue bars there. And then the top blue bar is your own self-assessment against those, where we help you by asking you questions. Are you doing this? Are you adhering to this control? And then you fill that in, and then we give you a score, and we also give you a level of risk associated with it by us looking at those different controls and identifying which ones put you at most risk with those certifications. And then based on that, then you can prioritize what you need to go do to get your compliance up to 100%. And so that tool is free for anybody to use. It's available right now. Now, I was trying to figure out where to put blockchain in this talk, because blockchain is such a revolutionary technology, and I know that blockchain is of intense interest here in Switzerland, given its likely applications in financial markets. And trust seemed like the best place to put it, because blockchain's all about trust. It's about a consortium of companies that can operate with each other with minimal trust, without having to depend on one central authority to do the right thing. And by distributing that trust in the way that blockchain allows you to do, with an immutable ledger, now you've got full transparency across what's going on, and you get instant transactions with no clearing times, no settlement times. And so this kind of technology is going to transform not just financial, but a whole bunch of different sectors. I mean, you see it being applied in things like digital music rights management, like who's the artist that owns a particular, or who's the company that owns the rights to a particular song. If that could be tracked in one place transparently, then artists could get paid, ensure that they get paid. Whereas today, that information is distributed across databases all over the place. In many cases, even if a company wants to pay the artist, they're not sure who's the one that they should pay or how to pay them. So blockchain is a place that we focus, and we're focusing in a number of different ways. One of the ways that we're doing this is with blockchain as a service, where just like with IoT, you can go and deploy pre-canned blockchain networks on our cloud with just a few clicks. We're also working on a platform that is more like blockchain SaaS, where you can write smart contracts, which are really where the power of blockchain for consortium networks comes into play. And then we take care of everything underneath, the management of the whole network. And then we do identity, we build an identity and key management and analytics on top, where you just focus on the smart contracts, the logic of your blockchain application or solution. We're also looking at ways to overcome some of the limitations of blockchain. So if you take a look at blockchain, Ethereum's network, the Ethereum blockchain network, which is the most popular one used in business to business, the public Ethereum network can be deployed in a consortium mode privately, and you can do that in Azure through our marketplace. You can deploy the Ethereum network. But the limitations of blockchain show up very clearly in the Ethereum network. Because it's fully untrusted, it's got a consensus algorithm that's based on something called proof of work, where miners that are adding transactions to the ledger have to prove that they're trustworthy, and they do that by doing a bunch of wasted work, solving cryptographic puzzles. What that does is waste energy, of course, but it also slows the transaction rate down, in the case of Ethereum, to about 5 to 15 transactions per second. And the latencies now in achieving consensus mean that a transaction you might not be able to consider as final for minutes, even though it takes just a few seconds for the transaction to actually occur, be executed. And that's because of the network needs to agree on the order of transactions in the blockchain network. So we've been working on, hey, what can we do to make blockchain more efficient? And this is where another effort we've got called Azure Confidential Computing intersects with blockchain. With Azure Confidential Computing, we're leveraging a new type of technology called Trusted Execution Environments, or TEEs, that let you put code and data into a black box that's protected either by software or hardware from the environment around it. The most common hardware TEE is something called Intel Software Guard Extensions, or SGX, which comes in their Skylake processors. And with that, you can put code inside of the SGX enclave, or the black box. Nothing else on the processor, or the operating system, or the hypervisor can see into that black box or manipulate it. And that allows you to put code in there with data that is encrypted to that code, knowing that that environment can't access that encrypted data. The enclave can also prove that it's trustworthy. It can prove to the outside world, hey, I'm running this code, this specific code, by getting an attestation from the processor itself that says, this is the code that I've put in the black box. And if you take a look at the power of that, that means that you can put data in a place like a cloud provider where you don't have to trust Hyper-V, you don't have to trust Microsoft, you don't have to trust government entities that might come and say, Microsoft, give us this customer data, because we technically cannot comply, even if we're obligated by law, and we do want to, of course, be law-abiding. When a government comes and says, under proper legal conditions, give us this customer's data, we are obligated to comply. In this case, even though we're obligated, we simply cannot, because the black box is protecting that data. And if you take a look at what you can do with that, you can build something like a confidential network of blockchain nodes that have their code running inside of those enclaves, such that it doesn't matter where those enclaves are. It doesn't matter if it's running in my SGX node or yours, because we both trust Intel technology to protect that code and data from each other. Even if somebody malicious gets into our networks and tries to get at it, we know that the black box is going to protect that code and data. Now, we can trust any of our black boxes to give an answer for a transaction without having to go and re-prove it and re-verify it and do consensus. We boiled the problem down into a traditional consensus algorithm with that would be applicable to any distributed application, even in the fully trusted models. And with that, we can achieve transaction latencies and transaction throughputs that are very much like a traditional distributed application, like a distributed database. What we're doing is we're taking and building this framework on top of Azure Confidential Computing as something called Cocoa Framework that will be open source and available for integration with different ledger technologies. And we're integrating, right now, Ethereum. We're also working with Intel on integrating Sawtooth Lake, and we're working with R3 to integrate Corda onto the Cocoa Framework, which any arbitrary ledger can be integrated with to take advantage of those properties. I want to show you last demo here, which is Cocoa Framework. In action. And this Cocoa Framework, here we've got two Ethereum networks side by side. One of them on the left is running Ethereum integrated with Cocoa. So this is off-the-shelf Ethereum with some minor modifications that allow it to run on top of this confidential network based on software guard extensions. Four-node network. The same four-node network on the right side is running the public Ethereum code with no modifications, doing the standard proof-of-work consensus. And what you're going to see is that we're feeding it 2,000, both these networks, at the same time, 2,000 transactions recorded off the public Ethereum network. We're just giving those transactions, having them execute those, and you can see on the left side, the Cocoa-enabled Ethereum is already finished. In fact, it finished in just a couple seconds. processing all 2,000 transactions. Average latency of a transaction was 125 milliseconds. Got a throughput of about 1,600. You can see in the middle of the dial, 1,600 transactions per second. Now, the off-the-shelf Ethereum on the right side, it is still processing. And I'm going to fast forward here because it takes it quite a while. It takes it several minutes to actually finish. You can see the transaction rate is about 12 transactions per second. It hasn't even finished at this point, and you can see the average latency is in the minutes. And that is what you get with off-the-shelf Ethereum. With Cocoa, you also not only get this improved latency throughput, but you also get confidentiality, because now, instead of everybody having to see all the transactions, Cocoa can be used to hide transactions or make transactions visible only to those parties that should have access to them. And as far as where Cocoa is available and Azure Confidential Computing is available, Azure Confidential Computing is in a private preview right now. If you're interested and you have a real scenario that you believe you want to work on very quickly and bringing out and testing on top of confidential computing, we're the only cloud with SGX-enabled servers, then contact me, and I'll connect you with the right people. And as far as Cocoa, we're working on that. You'll see in just a few months, we're going to be open sourcing the whole thing on GitHub. You can run it on Azure. You can run it on your own nodes. You can run it wherever you'd like to. It's something we're just contributing to the ecosystem to make blockchain for enterprise better. So with that, I want to wrap up. And thank you very much. I apologize again for the short period of time. I wanted to focus on just a few things that I thought highlighted our differentiation and showed you some of the power of the cloud and give you some view of the direction the cloud's going. I know I found out this trip to Switzerland with the tour guide that Switzerland has 4 official languages, which I didn't realize. So I've said thank you in all 4 languages. Does anybody speak Romanish in here? Anybody? I understand there's only 60,000 Romanish people in the country. So I was hoping at least a few of them would show up here, but apparently not. So if you see any of them, tell them I was looking for them. Oh, there's one over here. All right, with that, I want to thank you very much. Have a great 2 days, and good luck with the cloud and Azure.
Thank you, Mark. Thank you.
Thanks.